Hi guys, today I wanna give you some insights of the functions and the code of the post processor for my foam cutter. So everything is divided into two main classes. One is the view controller itself, controlling everything which got to do with the interface, the tables, the buttons, and so on. So that's here you place the code for the interaction. Um, uh, the the second part and the more interesting part is the fcalc. This is the calculation, and inside here you we have all the math and all the things required to calculate your movements for the machine and generate the G code. So the usage is quite simple. We have settings. All settings can be accessed over an interface function. So settings are all these things here. So I have a machine, depth, height, and so on, and the labels. So and I defined some keys for the settings, and you can get the label for that key, you can get the value for that key, and you can get the data type of that key. Data type is, for example, it's an int, it's an checkbox, or it's a double, or a boolean. This got nothing to do with the format itself, so the exchange is always a string. It's got more to do with the way you visualize it. For example, here, checkboxes, I use a checkbox and not a 0 or a 1. When I want to write it, I can check if that value is editable, so I get true or false. I can send over a value string to check if that string is valid for that setting. So that's a kind of pre-check. If I entered some stupid letters or chars, then I would get a false. And in the end, I can really write the value with the value for key, where I hand over the value itself to that key. So with all the settings done, I can go to the next, the load of a file. We have support of different file types. It's the G code or NC. Actually, I'm using simple ones, which I generate from my SketchUp plugin, or HOV, which is the file format from WingHelper with the ICE export. You use it with a load shape from file and just hand over the string of the path, including file name and extension. You can save the G code with that command, save G code to file. So pretty simple, pretty straightforward. When you want to change the values or the coordinates, as I did in the example, you can do that with accessing the single entry points. Therefore, you can ask the number of the positions, the number of the lines that I have inside, and you can get the value of the position on that index with the key, position table key. Therefore, you see we have some keys here, so you can get access to the axis, to the block, and to the shape hotwire pre-travel, and so on. Writing is done in a similar way as the settings. We can check if the format is right and then write it. And you can even delete a whole line or add a whole line. For interaction with the user interface, I defined 3 callbacks. It's the update position table view. So whenever fcalc thinks I need to update something in the positions, then it's calling that that function, and it's also giving or handing over an index. If that index is 0, you should update the whole table, otherwise only that line. This is done, for example, if you rotate your shape within the settings, then all the positions are changed and you will get an update. The other thing is updating the settings table view. This is called when settings have changed. For example, when you do a load, I reset all the orientation, like the angles and the flip and the mirror things. Last and very important thing is the update preview. This callback is called whenever I think the preview needs to be updated. So I hand here directly scene kit nodes. This is very common for 3D graphics in Swift, and these functions need to be changed if you go to another system. The points itself are available inside my positions, so pretty easy to adopt and draw the graphics.